Hi, Math 30-2s. Welcome to the first lesson for your last chapter of the year, which is probability. So the majority of today's lesson is just dealing with and understanding the terminology we're going to be using throughout this chapter. So a highlight or something to underline with would be a good idea. We will deal with some questions towards the end of this lesson, but the majority of the beginning anyways deals with all the bolded words you'll see, okay, and what they mean and what we need to know about them as we kind of move forward here. So just as a review, it says the following simple probability questions were asked in junior high math. A fair die is rolled. What is the probability of rolling a 1? The next one, a circular spinner is divided into 4 equal sectors labeled clubs, diamonds, hearts, and spades. When it is spun, what is the probability that it lands on hearts? 2 coins are tossed and the number of heads is counted. What is the probability of obtaining 2 heads? And it says at this time, do not calculate the probabilities, just questions that we want to start to consider and think about, okay? So here we just jump into the terminology, okay, and things we need to know and recognize as we read questions. It says, probability theory deals with the mathematics of chance or prediction. The following terminology will be used. So first word is a trial, okay? So a trial is an operation whose outcome cannot be predicted with certainty. So a coin is tossed, a die is rolled. Next, an experiment, okay? An experiment consists of one or more trials. So every time you do something, it's a trial. And if I do it more than once, it's an experiment. So a coin is tossed, 2 die are rolled, a coin is tossed and a die is rolled, okay? And the outcome is basically the result of carrying out the experiment. So H would be heads, 6, 4 would be the 2 numbers on the dies, or tails, 4, okay, would be the third outcome that they have there, okay? The sample space, okay, so now we talk about sample space, which they will label as an S, okay, is all of the possible outcomes. So when they say list the sample space, you're trying to write down every single possible outcome that could occur. So for example, for HT, okay, heads, tails, okay, 1, 1, a 1, then a 2, all the way up to 6 and a 6, or heads 1, heads 2, okay, all the way down to tails and 6. So all of the possible outcomes are listed in that sample space, okay? An event is a subset of a sample space. It consists of one or more of the possible outcomes of an experiment. So just heads, okay, or 1, then a 4, and then a tails or a 2. Those are subsets. Those are one events that could possibly happen, and they're just one example of the sample space. Okay, next, to denote the probability of an event A, we write PA. So when I'm talking about the probability of A, this is how I notate it. P, K, and A in brackets. That stands for the probability of A. Now, probabilities are usually represented by decimals or fractions that are between 0 and 1, okay? So for any event, the probability of A will be between 0 and 1, okay? Decimals or fractions. If the event X does not include any of the outcomes in the sample space, then it's impossible. It can't happen, and we would say the probability of that event, which in this case is X, happening is 0. So an example of that right here would be like the probability of rolling 9 on a standard die. Now a standard die means 6-sided, okay? So the probability of rolling a 9, well, that's 0 because the 9 does not exist on that die. If the event Y includes all of the outcomes in a sample space, then the probability that it's going to happen is certain. It will happen for sure, so it's the number 1, which is equivalent to 100%. So, for example, the probability of rolling a natural number less than 7 on a die. Well, natural numbers start at 1 and go 1, 2, 3, 4, 5, 6. So the probability that you're going to get the number 1, 2, 3, 4, 5, or 6 is 100%, okay, or the value of 1. Okay, so again, all important terms and terminologies and notation that we have to know moving forward. If an experiment has what we call equally likely outcomes, then the probability of an event A is given by this formula. The number of outcomes favorable to A over the total number of outcomes. Okay, so for example, the probability of getting heads on a coin when you flip it is 1 out of 2. Okay, the heads and the tails are equally likely outcomes. There's 2 outcomes, and we want 1 out of those 2. So let's take a look at a question here. It says, consider the first 2 examples from the review. A fair die is rolled. What's the probability of rolling a 1? And a circular spinner is divided into 4 equal sectors labeled clubs, diamonds, hearts, and spades. When it is spun, what is the probability that it lands on hearts? Okay, so I'll deal with A first over here. Okay, and in the first case, or in the first example, the first part is they want the sample space. So a fair die is rolled. So when I roll a die, all the possible outcomes or the sample space are the numbers 1 to 6. Okay, those are all the possible things that can happen. Okay, 2, the favorable outcome in the sample space. Well, that's what we want to happen. And they said, what is the probability of rolling a 1? So in this case, okay, the favorable outcome is getting the 1. So the favorable outcome in the sample space is getting the number 1. Okay? The third thing says, in each case, state if the outcomes are equally likely. Well, the outcomes are all equally likely because I'm rolling a fair die. Okay, a fair die again means 6-sided. It's not like, a cheating die where one side is weighted more heavily than the other. Okay, so yes, the numbers 1 to 6 all have the same chance of ending up when I basically roll it. And then what would the probability of the event being? Well, I want one outcome out of a total of 6. So the probability of getting the 1 is 1 out of 6. Now, for B, or the second one, the circular spinner. First thing they want me to list, okay, again, is the sample space. So we have clubs, diamonds, hearts, and spades. That is the sample space here, so I just write that down. Okay, clubs, diamonds, hearts, okay, and lastly, spades. Okay, those are all the possible things that could result in this question. The next is the favorable outcome, and the question was, what's the probability of it landing on hearts? So hearts is the favorable outcome in this scenario. Okay, are the outcomes equally likely? Yes, because it says 4 equal sectors. Okay, so the sectors are equal, so yes, equally likely. Okay, and the probability is the 1 sector out of the 4, and since they are all equally likely, okay, 1 out of 4. Okay, what I want to happen out of the total number of possibilities. Okay, so the next key term we're going to take a look at here is complementary events. So it says when the spinner in B is spun, the sample space consists of the 4 outcomes: clubs, diamonds, hearts, and spades. The event lands on hearts consists of 1 outcome out of 4, so therefore the probability is 1 out of 4. So the complement to that would be does not land on hearts and would be 3 out of 4. Okay, remember that those two complementary events are going to add up to the number 1. Okay, so what I want to happen plus what I don't want to happen should end up equaling the number 1, or 100%. So that's what they talk about now. The event does not land on hearts is the complement of lands on hearts. Okay, they are called complementary events. Okay, so those are things we want to make sure we understand. So, and here's the key point that I just mentioned. Okay, the probability of an event and the probability of the complement will always add up to 1. The complement of an event is the set of outcomes in the sample space that are not included in the outcomes of A. So the complement of A, okay, this is important here, is denoted as this, A prime or A bar. Okay, so both of those mean the complement of A. You must know that, okay? The union of the set of outcomes for A and the set of outcomes for B will be the complement of A will be all the elements of the sample space. So, okay, sounds confusing, but again, all they're talking about is what I talked about above. The probability of what I want plus the complement, okay, must equal to 1. And that's exactly what they're saying here as well. It's just that in the first one, they're using A prime, and in the second one, they used A bar. But again, remember, those mean the same thing. Okay, so from review A, list the outcomes for the complement of rolling a 1, okay, and determine the probability of the complement of rolling a 1, okay? So what I want to do is the following. I want to list the outcomes, so not rolling a 1, okay, so that looks like what? Well, I don't want to roll a 1, so that would be a 2, 3, 4, 5, or a 6, okay? And then the probability of not rolling a 1, okay? There are 5 outcomes I just wrote there out of a total of 6, okay? And again, you can see that if I took that 5 over 6 and added it to the 1 over 6 that I originally calculated for rolling a 1, they add up to the value of 1, or 100%. Okay, next, compound events. Events formed from repeated trials or from a combination of simple events are called compound events. Okay, so that is important. And often a table, a chart, or a tree diagram is useful in determining the sample space. So consider the third review question, which says 2 coins are tossed and the number of heads is counted. What is the probability of obtaining 2 heads? Tyler lists the sample space as 2 heads, 1 head and 1 tail, or 2 tails. And the favorable outcome is 2 heads. So since there are 3 elements in the sample space, so he has 1, 2, 3 events in the sample space, and he wants one of them, which is 2 heads, he says the probability is going to be 1/3. Now, why is this not the case? Okay, and that's what they ask in A. Why is this not the case? Well, it's because the outcomes, okay, in this case, are not equally likely. Okay, we're going to take a look at why in a second and what that means. Okay, all those outcomes do not have the same chance of occurring. In the above example, the outcomes in Tyler's sample space are not equally likely, okay, just as we stated. So in the formula, the number of outcomes favorable to A over the total possible outcomes is not applicable. So we can study this or understand this a little bit better using a tree diagram. So you can see that there are basically 4 outcomes, not 3, okay? And the reason being is that if there's heads on the first coin, then I can have heads or tails on the second toss. If I start with the tails, then I can have heads or tails on the second toss. So getting a head and a tail, there are actually 2 outcomes there where I have 1 head and 1 tail. So when I go and determine the probability, well, the probability of 2 heads, we'll take a look at my tree diagram there. 2 heads, there's only 1 outcome with 2 heads out of a total of 4. 2 tails, the same thing. There's only 1 outcome with 2 tails out of the 4, but 1 head and 1 tail, there's 2 of those out of the 4. So it's 1/2. That is the probability there, okay? So 1 head and 1 tail, okay, there are 2 scenarios where that occurs, so those events are not equally likely. Okay, last page here. It says, consider an experiment of spinning an equally spaced triangular spinner, numbered 1, 2, 3, and tossing 2 coins. Complete the tree diagram, okay, to show all of the outcomes. So they've done the spinner part, 1, 2, 3. They started with the coin 1, heads or tails, so coin 2 could obviously be a heads or a tails, and coin 3 could also be heads or tails. Okay, coin 2, heads or tails, heads or tails. Okay, so I just fill in the HT all the way down, okay, for each of those offshoot outcomes from the coin 1. Okay, and then they want me to fill out the outcome. So how do I do that? Well, for example, the first one is I just follow the path. 1, heads, heads. That takes me here. Okay, the next one would be 1, tails. Oh, sorry, it would have been, I went the wrong way, didn't I? Okay, the second one could have been the 1, okay, heads, tails. Okay, and that takes me here. So the next one would be 1, tails, heads. Okay, so 1, tails, and heads, and then you would have 1, tails, tails. Okay, and then you just carry on. So the next one would be 2, heads, heads, and then 2, heads, tails. Then 2, tails, heads, 2, tails, tails. Okay, and then finally you have 3 heads, heads, 3 heads, tails, 3 tails, heads, 3 tails, tails. Okay, so I completed the tree diagram. So how many elements are in the sample space? Okay, well, I just count up the total on the outside. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 12 elements in that sample space, 12 total possible outcomes. Show how you can use the fundamental counting principle to determine the answer to B. Well, if you remember the fundamental counting principle, okay, this is kind of like step 1, this is like step 2, and this is step 3. So in step 1, there are 3 possibilities. And then I have step 2 where there are 2 outcomes. And then I have step 3 where there are 2 outcomes. So 3 times 2 is 6 times 2 is 12. Okay, the number of outcomes at each step along the way. Are all the outcomes equally likely? Okay, well, the answer is no. Okay, because again, some of them I have heads, tails, tails, head, which results in, okay, 1 head and 1 tail. So now they want me to determine probability. State the probability of obtaining a 3 and 2 heads. So they want the probability of this, a 3 and then 2 heads. Well, the probability of that occurring, there's only one of those events out of the total of 12. Okay, so 1 out of 12. Next, they say a prime number. Okay, so again, remember a prime number is a number that's only divisible by 1 and itself. So that would be in this case 2 and 3, and exactly 1 tail. So I could have 2 heads, tails, or 2 tails, heads. Okay, or I could have 3 heads, tails, 3 tails, heads. So the probability there is, you can see there are 4 outcomes that I wrote out of the total of 12, and we always reduce, so that is 1 out of 3, okay, the probability. Okay, last question. A blue die and a red die are rolled. The outcome 3 on the blue die, okay, and 4 on the red die can be represented by 3, 4. So the first number is what comes off the blue die. The second number is the one that comes off the red die. Okay, show all the possible outcomes in the array. So you need to go through, okay, and you need to fill out this whole chart. So 1, 1, okay, then 1, 2, okay. So let's just take a moment for myself and yourself to fill this out so that we have all of the outcomes, okay, in front of us, so that when we go and answer a question, okay, visually we can understand what is being asked of us. Okay, so just bear with me as I go through here, fill in the chart. Okay, and you can also do the same thing wherever you are doing this assignment today. Okay. You know, halfway there pretty much. All right, thank goodness. Okay, so how many points are in the sample space? Okay, well, this is a 6 by 6 grid, so there will be 36 total outcomes, okay, or spaces to be filled in that grid. List the event, the same number appears on each die as a subset of the sample space. So they just want you to write out the same number appears twice. So that's, for example, that would be 1, 1, 2, 2, okay, 3, 3, 4, 4, 5, 5, and finally 6, 6, okay? And again, all of our information is contained within those curly or squiggly brackets. Now, state the probability of the following events. The same number appears on both dice. Well, that's kind of what I did up here. I wrote out the sample space, and you can see in that sample space there are 1, 2, 3, 4, 5. There are 6 of those outcomes out of a total of 36 on the grid. So that's a probability of 1 out of 6, okay? Now, a different number appears on each dice. Well, that is the complement, basically, of what I just did, isn't it? Because I figured out all the ones where they are the same. So if there are 6 out of 36 where they are the same, that would mean there are 30 out of 36 where they are not the same, and that reduces to 5 out of 6. How can the answer in D, part 2, which is what I just did, be determined using the answer in D? Okay, well, that's what I just talked about. So D, part 2, is the complement, isn't it? Okay, so it's the complement of D, part 1. Okay, and that's just what I said. So basically what you could also do is you could go 1, okay, minus 1 over 6, which also equals 5 out of 6, doesn't it? Okay, because remember, when I take the probability and its complement and I add them, they always have to add up to the number 1 or 100%. Okay, so there you go. There's your first lesson for probability. Try that tonight, see how you guys do. Check the Google Classroom if you haven't already for the test date on perms and cons that's coming up next week. Have a good